All right, starting lesson 7.4, solving polynomial equations in factored form. Okay, now here we have this binomial here. Binomial meaning there are two terms. Okay, and we're going to factor it. Now this tends to be a bit confusing for students in the beginning, but it's actually a very simple concept. So let me take this x squared and break it down into its parts. X times x, and then I have plus 2x. Now if I ask you to factor this, okay, I want to know how many variables I could pull out of each term. And I have to pull the same amount out of each term. That's key, the same amount. So here I have 2x's, and here I have 1x. So if I have to pull the same amount of variables out of each term, how many can I pull out? Well, I only have one here, so that means I can only pull one out of here as well. So you can't pull out two, because this one doesn't have two. All right, so we only can pull out one. So I pull out one, and then you write parentheses, and then you need to ask yourself, x times what gives you x times x? Well, we just need another x. And then x times what gives you 2x? Well, that would be 2. All right, and then we have a plus in between. Now, the nice thing about factoring is you know if you did it right or not, because you can always go backwards, and if it takes you back to what you started with, you know you did it right. So here I have x times x, that's x squared, x times 2, that's 2x. So I know I factored it correctly. All right, now how to factor a trinomial of this form, that explanation is a bit more lengthy, and that's going to come up in future lessons. All right, then we have the zero product property rule that we will be applying in this lesson. Now, if I have a times b is equal to 0, then that tells me that either a is equal to 0 or b is equal to 0. All right, one or the other has to be equal to 0, or both, all right, in order for the result to be 0. And we're going to use this property to help us solve some of the problems coming up. All right, so example 1, solving polynomial equations. They already have everything factored for you, so we don't have to do any of the factoring work yet. We just have to solve. So here I have 2x times x minus 4 is equal to 0. Well, just as we discussed in the previous slide, if you're multiplying two quantities and the result is 0, then one of them has to be equal to 0. All right, so we set 2x equal to 0, and we set x minus 4 equal to 0. All right, so we have two equations now, and we're going to solve both of these. X equals 0, and then I add 4, and I get x equals 4. All right, so I actually have two solutions in this problem. Now, what do these solutions represent? They represent the values of x, such that if I plug them in, the result will be 0. All right, it's as simple as that. That's why they're called zeros. Here I'm multiplying these two quantities, and the result is 0. So I set each quantity equal to 0 in order to solve for x. Here I add 9. All right, it's as simple as that. So once again, what do these solutions represent? They represent the x values that when I plug them in, the result is 0. All right, when two or more roots of an equation are the same number, the equation has repeated roots. All right, solve each equation. Same thing as what we did before. 2x plus 7 equals 0. 2x minus 7 equals 0. All right, just take your time working it out. All right, simple as that. Part B, okay, here's where students get confused. Now, I know that x squared is the same thing as x times x. So x minus 1 squared is the same thing as x minus 1. Let's use blue here. X minus 1 times x minus 1. All right, so I set x minus 1 equal to 0. I set x minus 1 equal to 0. add 1, add 1. All right, so here I have repeated roots, and you don't have to state the same root twice. So x is equal to 1, done. All right, on to the next example. Okay, I have to set all of these now, all these binomials, equal to 0. So I don't have that much space here, so I'm going to stack them. All right, solve each of them. All right, so I have x equals -1, x equals 2, x equals 3. All right, done deal. On to the next example. Factor out the greatest common monomial factor from 4x to the fourth plus 24x to the third. Okay, this is the very basic factoring problem. Okay, first, before we look at the variables, let's look at the number, 4 and 24. Now, answer this question. What is the largest number you can divide into 4 and 24? What goes into both? That's going to be 4. All right, 4 is the largest number that divides evenly into both 4 and 24. Okay, now let's look at the variables. Here I have x to the fourth, here I have x to the third. Now here I have 4x's, here I have 3x's. If you're going to pull out an equal amount of x's from both, what's the most you could pull out? Well, here I have 3, here I have 4. So I could pull 3 out of here, and I could also pull 3 out of here. Okay, so that works. That's the most x's you could pull out. Now we have parentheses, and you have to ask yourself, 4x to the third times what gives you 4x to the fourth? Well, that's just x, right? Because x to the third times x is x to the fourth. And then 4x to the third times what gives you 24x to the third? Well, 4 times 24, that's 6. And then x to the third times what is x to the third? Well, that's just 1, so we don't have to multiply it by anything. And then we just have a plus symbol in between. All right, now, here's the beautiful thing about factoring. You know if you did it right or not by going backwards. So I'll multiply 4x to the third times x gives me 4x to the fourth, and 4x to the third times 6 gives me 24x to the third. All right, so right away, you know that you factored it correctly. So I have 4x to the third times x plus 6. All right, this is the most basic factoring problem. If you don't understand this, make sure to ask, because all the future lessons are going to be very difficult if you don't understand this concept right now. All right, one last example. Solving equations by factoring. Okay, so bringing all the ideas together right now. All right, I have to factor this here. All right, so what's the largest number that goes into 2 and 8? That would be 2. Here I have 2x's, here I have 1x. What's the most x's I could pull out of each if I have to pull out an equal amount of x's? That would be 1. All right, now 2x times what gives me 2x squared? That's x. 2x times what gives me 8x? That's 4. All right, and we have a plus in between. All right, sorry about that. All right, now I'm going to solve the equation. I set each factor equal to 0. All right, here I divide by 2. I get x equals 0. That's still a solution. All right, so I have 2 answers for that problem. Next example. Okay, first thing you want to do is push all your terms to one side so you get 0 on the other side. Here I'll subtract 15n. Alright, so I get 6n squared minus 15n equals 0. Okay, now, what's the largest number that you could divide into 6 and 15? That would be 3. Here I have 2 n's, here I have 1 n. If I have to pull an equal amount of n's out of each term, what's the most you could pull out? 1n. Okay, now what's left over? 3n times what gives you 6n squared? That would be 2n. 3n times what gives you negative 15n? That would be negative 5. Alright, so now I set my factors equal to 0. 3n is equal to 0. And 2n minus 5 is equal to 0. Divide by 3. N equals 0. Add 5. 2n is equal to 5. Divide by 2. N is equal to 5 over 2. Alright, so those are my 2 answers. Alright, if you found anything confusing about this lesson, please make sure to ask for help. Okay, once again, these concepts are going to come up even more in future lessons, and we're going to be building on this idea in many lessons. So don't wait to ask for help. Ask for it now, so it doesn't become that difficult to learn in the future. All right, begin the assignment at the bottom of the webpage.